Hey guys, a very good day to you all. So in the last video, we have seen what is the process of electrolysis. In this video, we will be understanding different types of electrolysis using different molten solutions. The three molten solutions which we have considered in this video is the molten solution of sodium chloride, the molten solution of lead bromide, and electrolysis of water. Starting off with the video, we will first consider the electrolysis of molten sodium chloride. So what happens in the electrolysis of molten sodium chloride is that we have two electrodes, one which is anode and another is cathode. Now what is anode? Anode is an electrode which is connected to the positive terminal of the battery, and cathode is an electrode which is connected to the negative terminal of the battery. Since anode is connected to the positive terminal of the battery, anode is positively charged, and since cathode is connected to the negative terminal of the battery, cathode is negatively charged. In the molten solution of NaCl, what happens is that when we switch on the battery, there is a potential difference between the positively charged anode and a negatively charged cathode. Due to this potential difference, the molten NaCl breaks into positively charged Na plus and negatively charged Cl minus. As we all know that opposite charges attract each other, therefore Cl which is negatively charged will get attracted towards anode which is positively charged, and Na plus which is positively charged will get attracted to cathode which is negatively charged. Due to this attraction, all Cl ions will be formed near the anode and all Na plus ions will be formed near the cathode. Now, when these Cl minus ions get attracted towards the cathode, they will give one electron. That is, since anode is positively charged, it will attract that extra electron which Cl minus has. So why Cl is minus? Cl minus because it has one extra electron, and anode is positive, so it will take that electron from Cl minus. So Cl minus at anode will lose one electron and become normal Cl. The process in which there is a loss of electron is known as oxidation. Now the electron which is lost by Cl minus ion on this anode will travel through this conductor. This electron will travel through this conductor and it will reach the battery. After reaching the battery will push that electron towards the cathode. So this electron has now reached the cathode. When it reaches the cathode, cathode is negatively charged and Na plus is positively charged. Na is plus because it is deficient of electron. So the electron which is lost by the Cl minus travels through the battery to the cathode, and Na plus which is deficient of electron will take that electron. So Na plus will take that one electron and it will become normal Na. And the process where there is taking of electron, that is gaining of electron taking place, this is known as reduction. Now there is oxidation taking place as well as reduction taking place simultaneously in the process. Therefore the overall reaction will be a redox reaction. If we add the left hand side, the overall reaction will be Na plus Cl minus, which is giving rise to Na and Cl. This overall reaction, which we have already seen physically, that this Cl minus loses its ion, loses its electron and becomes normal Cl, and this Na plus gains electron and becomes normal Na. So this is what we are getting at the end, that is normal Na and normal Cl. Moving on to the second electrolysis of a molten lead bromide. Now in this process of molten lead bromide, lead which is represented by Pb2 plus. So lead, what is the formula for molten bromide? Lead bromide is that PbB2, PbBr2. So this PbBr2 will again get dissociated into Pb2 plus ions and Br minus ions. After they are dissociated into Pb2 plus and Br minus, the Pb2 plus which is at this cathode requires 2 electrons. So it will take 2 electrons and become stable into Pb. So In the reaction where there is a gain of electron, the process is known as reduction. And at anode, what is going to happen is that these two Br minus ions will lose one electron each. So two Br minus ions will lose two electrons and it will form Br2. So these two electrons which are lost by two Br minus ions will be taken by one Pb2 plus. Pb has two positive charges, so it requires two electrons. So Br minus 2Br will release two electrons, one each, and the electrons lost by 2Br will be taken by one Pb2 plus. The overall reaction will be 1 Pb2 plus 2 Br minus will give rise to Pb plus Br2, and the whole process is redox reaction because there is a reduction taking place as well as there is an oxidation taking place. Now comes the twist. Before understanding the electrolysis of water, we need to understand what is preferential discharge theory. So what is preferential discharge theory is that, suppose as we all know that at anode, which is positively charged, negatively charged anions will get attracted. But in the previous two examples, we had only one anions. That is, in the NaCl process, we had Cl minus, and in the PP lead bromide process, we had Br minus. But what if we have two minus, that is two anions of different element? Suppose we have SO4 2 minus and NO3 minus. So which of them is going to get discharged? So this preferential discharge theory tells us which is going to get discharged first. So as we move towards the right hand side, the potential discharge theory decreases. That is, if we compare Li and Au3 plus, if these two positive are present in one solution, so Au3 plus will first get dissociated. That is, it will first gain 3 electrons and then Li will gain 1 electron. So as we move towards the right, the discharge decreases and Au3 plus will easily gain electrons as compared to Li plus. In a similar way, for anions, OH minus will easily lose 1 electron as compared to SO4 2 minus. So you need to keep this preferential discharge theory in mind. Moving ahead to our electrolysis of water. Now, as we all know that water is a poor conductor of electricity. So in order to do electrolysis of water, we need to add H2SO4 to the water. Adding H2SO4 to the water makes it acidified. Since the water has now become acidified, it will now conduct electricity in a very good manner. But the problem arises here that since we have added H2SO4, H2SO4 will also get dissociated into H plus ions as well as SO4 2 minus ions. And as usual, H2O, that is our normal water, is obviously going to get dissociated into H plus ions and OH minus ions. Now we are left out with 3 ions produced. That is one which is H plus, SO4 minus, SO4 2 minus, and OH minus over here. So according to the discharge theory, at anode, anode is positively charged, so it requires negatively charged anions. We have 2 anions present over here, one which is OH minus, this minus charge, and SO4 2 minus. So which of them is going to get discharged is that, now we will refer the preferential discharge theory, the one which is on the right hand side. So OH minus is on the right hand side, so OH minus will easily donate 1 electron. So in the electrolysis of water, this SO4 2 minus will come after OH minus. Therefore OH minus will first lose its 1 electron, and the process in which there is a loss of electron, it is known as oxidation. Now what happens is that this OH has now become stable. After this OH becomes stable, this OH will again form 2H2O and O2 gas. See, this gas will be formed over here, oxygen gas. This change, which takes place after the initial primary change, is known as the secondary change. Till the first two electrolysis we have seen that there is only one change taking place, that is an anion is giving away one electron. But in the case of water, what is happening is that this OH, after becoming stable, it is again getting converted into H2O plus O2 gas. So this change which is happening after the primary change is known as the secondary change. Similarly, at the cathode, this H plus electron will gain one electron and it will get reduced. H plus electron will take one electron and it will become H. The stable H is now formed, and the process in which there is a gain of electron, it is known as the reduction. This is our primary change. Now, after this H is stable, H in a monoatomic state is never stable. Okay, so H is normal atom which is formed is never stable because it is in a monoatomic state. It needs to be in a diatomic state. Therefore, H plus H will combine and form H2 gas. So this is the H2 gas which you can see over here. So this change which is happening after the acceptance of electron is known as the secondary change. The overall reaction of this electrolysis of water can be given by 4H plus 4OH minus will give rise to 2H2 plus 2H2O plus O2, and this whole overall reaction is nothing but a redox reaction taking place, because there is oxidation taking place as well as reduction taking place simultaneously. So guys, thanks for watching this video. If you have liked this video, then please do subscribe to the channel and stay tuned to the channel. You will get all the videos related to the electrochemistry. So guys, thanks and share the channel.